Welcome to the channel 4, the demo channel here at Extreme Connect. My name is Alex Morrissey. I'm with the Technical Marketing Engineering Group based out of our Salem, New Hampshire office on the East Coast of the United States. I'm joined today by my colleague, Stefan, who's over on the West Coast of our San Jose office. And today we're going to talk about extreme fabric automation in your data center. Now, I'd like to lead off straight into a demo here. Just for reference, this demo is actually a pre-recorded demo. We're actually bringing a SLX-based fabric all the way from just having a management IP with just SNMP credentials all the way to an operational fabric. Some of these steps take a little bit of time, so in the nature of leaving plenty of room for Q&A here, we recorded it and are just going to shrink those weights down for you. After every command I run here, you're going to notice a little timestamp showing how long the command actually took. Overall, this whole process takes about 10 to 15 minutes from having no configuration except management all the way up to an operational fabric. So the fabric we're going to be setting up today is a 3-stage clove fabric. We have 2 spine switches based on 9250 switches, our SLX models, 2 pairs of leafs. One pair is 9140 and one pair is 9030s. And we also have a pair of border leaf routers, which are their 9540 model. Off of our 2 leaf pairs, we have a VMware ESX switch. These servers are dual homed, one to each leaf, and are hosting a VM on each. And this VM has 2 pings that we'll be showing later on, one going between the 2 VMs and one going out to the default gateway, which is located off the border leafs. So when first setting up the fabric, the first step is rack and stack. Establish your physical connectivity, and then apply a management IP address. In this case, I said we also had provided a SNMP config. After doing that, you can deploy your EFA VM and then log into EFA. So when you first connect to the server, you additionally need to log into the EFA application. EFA has role-based access controls, so you can limit what particular users have access to. Once you're logged in, the first step is to create the fabric. EFA has the capability to manage multiple IP fabrics at the same time. In this case, we're creating a 3-stage clove fabric with the name of Connect. After creating the fabric, now we need to add the switches into this fabric. This can be done in a variety of ways. You can add them one by one through either the fabric device command set. You can do it through our inventory system, or as I did here, add them in bulk. So in order to do this, it's one command. It's EFA fabric device. We're adding bulk. We're specifying the fabric we want to add the devices into, and then the IP addresses of each device and what their role is, whether it's leaf, border leaf, spine, or super spine, along with the access credentials. Once the switch has been added into EFA, EFA will log into these switches using the netconf config from EFA down to the switch, bring up the interfaces to determine how they're connected. And when we bring the interface up, there's no VLAN switching or IP interfaces, so there's no data path. We're just bringing the interface up and looking at our LTP neighbors to determine how things are interconnected. If there's a missing link or something is not configured the way it should be, EFA will present a warning telling you that you need to go check these devices for a missing link. EFA will also look at the switch models, the switch firmware, to make sure everything that you want to do is supported. So far, we've created the fabric, we've added the devices to the fabric, and we're about minute and a half here into the process. The next step is to actually tell EFA to go out and configure the fabric. Now, this is one of the big time-saving pieces. So with one command, EFA fabric configure with the name of the fabric. EFA goes into the switches. It configures the IP addresses of all the interfaces, the router BGP configuration, so AS numbers, loopback IPs, all that. And it does all this simultaneously across all the switches. So you've gone from management-only configuration to a functioning underlay ready to start provisioning services in about 3 to 4 minutes, 5 on the outside. As you can see here, the command took about 1 minute, 48 seconds. Now, once the fabric's been configured, it's the underlay, you can actually see what your topology looks like. So EFA gives you the ability to look at the physical topology, and so where the interfaces are actually linked and connected to. It'll show the switch, its role, what the other side of the link is for a switch IP and its role, and the ports involved. The other thing we can look at this point is the fabric topology underlay. So this is all your IP interfaces, the neighbors that you're using, BGP-AS numbers. Once we provision services, if you want, you can then look at the overlay and see all your VNIs going across the network. So now that we have the fabric running, now we need to start provisioning services. The first step of provisioning a service is to define the tenant. A tenant can be a department, a customer. If you're not having multiple users or applications on your network, you could have just one global tenant. The tenant is just a collection of physical resources that can be assigned for services. So in this case, we're provisioning the ports our servers are connected to. So we have 4 ports, one on each of our border leaves. And because we're only doing the one tenant in this environment, we actually have a VLAN range of 2 to 4090. This reserves these resources for this tenant and any services that we associate with the tenant. Now, the next step is our ESX servers are configured with a lag. So we're running LETP-based lags. In order to bring that lag up, we're going to provision the switch ports into port channels. This is done very simply from EFA. We name the port channel we want to use. We specify the link speed, the negotiation state for LETP, whether it's active or passive, the ports involved, and which tenant this port channel belongs to. That's key because when we later on associate our EFA with our VMware environment, it will actually pull those names we defined into some of the output, which we'll show in a little bit. Now that we have the port channels and the physical connections defined, now look at the logical connections. Now at this point, we're looking at EFA tenant endpoint group show here. The shows that we have nothing configured. Now an endpoint group is the logical service running within the tenant. So this would be the actual connectivity that we're providing between the hosts. In this case, we're going to be provisioning VLAN 101. So establishing that L2 connectivity from one ESX host to the other and eventually out to the internet. And to show that the connectivity is not currently there, I'm going to take a look at our 2 VMs. These are fairly simple VMs. We're going to have 2 pings on each. The green box is showing the VMs pinging each other, and the orange box is showing pings to the default gateway, which I said is off the border leaf routers outside the fabric. So because we're using VMware, we can leverage EFA's ability to integrate with vCenter to dynamically provision services based on VMware's distributed port groups. So the first step is to register EFA with a vCenter. This is used a host, username, password, and the tenant you want to associate this integration with. Once this is established, EFA will then go out to vCenter, look at its configuration, look at any distributed switches that are configured on the host, look at the the LEP neighbors of the physical ports of those switches to see where that switch connects into the network, and then look at the port groups defined and what VLANs are associated to each port group. We can see this information within EFA. I apologize. We can see the information in EFA looking at the port groups that have been dynamically created. In this case, we see that we have our Fabric Management 101 from the vCenter 1016.160 is associated to tenant A. We can see the port channels involved, in this case, ESX8 and ESX7, which we had defined previously, and the VLANs involved. So in this case, VLAN 101, we see its provision, it's in sync with the devices. At this point, that VLAN config has been pushed down to those border leaves and connectivity established between the hosts. We can also look and see just what those physical links are by looking at more output from vCenter. We can see which the host is, what the NIC card on the ESX host is, what the switch interface is, and the IP associated, as well as the port channel information. So if we go look at the switch config, we'd see port channel 1 with the name of ESX8 or ESX7 and the appropriate ports associated. Now, if we go back to our VMs that we had earlier, we can see that the pings between them are working. However, the pings to the default gateways is not working currently. So the next step we want to do is go manually configure our border leaf port to extend that L2 segment all the way out to that point so we can reach our default gateway. Now, earlier we defined our tenant with the 4 server ports. Now we need to update that tenant to add in our border leaf port. In this case, we're looking at 10.16.182, port 48. We've added this port into our tenant, and now we can use it for providing services. So this command's a little interesting because we're manually defining a new port group. We're doing naming it VLAN 101 handoff. We're associating with tenant A. We're adding the port that we had previously defined, VLAN 101. All this is in line with what we saw earlier. The key part is the switch port mode access. So we're actually configuring this as an untagged port for an uplink port. By default, EFA wants to configure ports as trunk ports. In this case, we're going into a flat switch with no VLAN config on it, so we're egressing untagged. Now, if we go, excuse me, now we can go do look at our endpoint groups again. We'll see that we have the dynamically created vCenter port group, and we'll also see that we have VLAN 101 handoff that we manually defined. You'll notice between the two that on the dynamically created one, we see the port channels. We're on the manual one, we actually see the specific switch IP and the port involved because no port channel is involved. Now we go back to our VMware host. It takes a little minute to kick in because of ARPs, but now we'll start seeing our pings to our default gateway succeeding. So in about 10-ish minutes here, we've gone from a switch with just management IP, SNMP configuration, all the way up to BGP fabric configured and services provision to allow VMs to talk between our servers, as well as to our border leafs off to the default gateway. So at this point, I'm going to pause here. We've our fabric operational. Just want to see if there's any questions.
Hey, Alex, great demonstration. We do have a few questions here from our viewers. First, is there a GUI or graphical user interface for EFA?
There certainly is, and that's a great question. EFA acts as a middleware in most cases. So while you can directly configure your fabric from EFA, it also has a northbound API. This API can be accessed from workflows within XMC, which I'll show in a moment here, as well as any other management application that you may be running. So in this case, I'm going to bring up our Stream Management Center here. You may have seen at the beginning of the video, we had a topology where all the links are red. That was in an unconfigured state. Well, now all our links are green. We've been configured. Everything's operational. Now, over in our workflows here, we have many workflows that have been developed for EFA that are available up on our GitHub. In this case, we're going to look at this one here. This particular workflow allows you to add a tenant port. So when we added our border leaf port into a tenant A, this would be a GUI interface that you could utilize to do that. When we run this, we're presented with two options: what tenant you want to add to and what port you want to add to. So in this case, we use tenant A again, but I'm going to change this to be 10.16.181. This is our other border leaf. We're still going to use port 48 for consistency's sake. And we can run this. Now, what the workflow is going to do is it's going to reach out to EFA via that API that I mentioned and provision that service for you without you ever actually having to log in. Once complete, we can go in and see the output and see that tenant A has been updated. And we now see that 10.16.181 has been added for a total of 6 ports. Additional workflows you could run is you can create the entire fabric this way if you would like to. We'd previously done that. I can show that to you. So this is a different workflow that we had run earlier. A little more complex. Again, it's all using API to do this. I'm going to actually go down here, look at the results, where you actually went in and it creates the fabric name. It will add the device to the fabric and then push out the config. All this was done with just a few options selected to the GUI. If you have any interest in actually running these workflows in your own environment, they're available up on our GitHub, which is github.com/extreme networks. if you go down to the extreme scripting section, net site, one view workflows, you'll see a whole section on Fabric automation. There are many workflows here, so for convenience sake, at the bottom there is a bundled zip package you can download and then import those into XMC. Now that covers the question there. Any others, Stefan?
That's great. Now, where can we find these API documentation?
So the API for EFA is available in a few places. The first place to go look is developer.extremenetworks.com. This is the online repository. When you first connect in, there's a few different options here for our different applications. In this case, we'll look at Extreme Fabric Automation. And each of these is a module within EFA. EFA is built on a containerized methodology. So each of our applications within EFA is running on the Kubernetes. So we have a service for Fabric management. We have a service for tenant provision. We have a service for inventory and for the integration points. So each of these has its own unique API. In this case, we bring up the tenant service. It provides all the documentation that you may need to go and develop your own API calls. You can actually expand these out. The other place you can go look is actually on EFA itself. This documentation is built right into the product. So if you were to bring up a web browser and go to your EFA DNS name or management IP /docs, connects to the same API documentation right on the platform. In this case, we're again looking at the tenant service. You can see all the different services we have running at the top here, as well as samples of the API calls that you could do. So it's whichever way works better for you here. You can access it online or directly from the device. Any other questions, Steve?
Great. So earlier you demonstrated that EFA learns the VLANs from VMware. But what if I create a new VLAN? Will EFA automatically add new VLANs as they are created in VMware?
That's a great question, and the answer is yes, it will. It'll create and delete. So, for example, if I bring up our EFA here, we're already logged in, so we can do EFA. We can see that same place we left off from the video here. We have the dynamically created endpoint group for the Fabric management, as well as our static port group we had created. Now, if I go into our vCenter appliance here, we have our Fabric DV switch with the management 101. I can create a new port group. So in this case, we'll do 102. We're going to specify our VLAN ID. In this case, I'm customizing this because we're using LECP, so we're going to adjust our uplink ports to use lag ports. So lag. Next. All right. So now we have VLAN 102 created here. We can actually go to our VMs and flip the port group over. And we'll notice that the pings are now failing for this from both for VM to VM because we only moved one VM as well as the default gateway. And we move our other VM. We now see that the pings between the VMs is working while the default gateway is still failing. This is because we don't have a internet access port for the VLAN. But if we go into EFA, we now see that we have our VLAN 101 that was dynamically created. We see our static one for 101. But we also see this port group, which is new for VLAN 102. Again, both port channels are automatically associated. And the VLAN ID is here. Now, if we want to get rid of this, We just flip our VMs back real fast. And you can see now both pings are succeeding, showing that we're back on that VLAN 101 where we have the internet connectivity. And we'll just delete this port group. So because EFA has been registered with vCenter, we see all the port creation and port deletion messages and are able to react to those. So now when we go back in and look, we only have our 2 port groups, the dynamic 101 that we created from VMware, and then our static uplink. So now we've added and deleted dynamically. So, I think that covers that one. Stefan, any other questions?
Awesome. Now, where is EFA hosted?
So EFA can be hosted in a few places. In our case here, we're hosting it as a VM on VMware. It could also be installed as bare metal. And for smaller fabrics under the 24 node-ish, it can be hosted on some of the SLX switches as an onboard VM. Specifically for the latest EFA, we'd be looking at the 9150, 9250, and the 9740 models for that. That onboard switching works for smaller fabrics, so the about 24 nodes, where the VMs and bare bones can scale much larger, pretty much as large as you need.
Okay. What hypervisors are supported for these integrations?
So currently, EFA supports 3 different hypervisors. We have VMware, we have Hyper-V, as well as OpenStack. There are future hypervisors they're looking at, but that may be implemented. But for now, right from EFA, you actually see that there's its own command set for Hyper-V, the vCenter, and OpenStack. And they all configure in a similar manner. We're integrating with the hypervisors to dynamically learn what services are needed. All right, next question, please.
I think you may have mentioned this before, but does EFA support role-based access control?
It does. The nice part about EFA is if you're not 100% sure of the commands, there are help contexts as you go. So in this case, we have, these are the currently configured role-based access control for EFA. I can see our default user of Ubuntu here, and it's been authorized for various tenants or roles within here. You can restrict a user to only be able to access a particular tenant if you'd like to. So if you have a one department or 2 different departments hosted on EFA, you could give a department A login for their stuff, and department B its own unique login. For more information, I'd recommend reviewing our documentation. There's a whole section on role-based access control.
Awesome. Seems like someone here asked, can you demonstrate drift and reconcile?
So looking at the time, I'm not going to actually demonstrate at this time. However, I will show you some previous demonstrations we've done. Now, drift and reconcile gives you the ability to check a switch's configuration, whether you did a firmware upgrade or someone may have accidentally configured it manually, and make sure that the configuration running on the switch is what should be. So check for any configuration drift, and if there is, reconcile that configuration to be correct. And all of this is also recorded within EFA. So in this environment, we've done a few of these over time. And you can actually go back and look at the history of them and see what a particular check had happened. So in this case, we ran a drift and reconcile check against our border leaf. We lost connectivity for some reason. We want to say, why is this broken? So to run it is, oops. Do that. You specify that you want to go do the check. You specify which IP of the the switch that you want to check is, and then whether you want to reconcile. So you can do just the check, or you can do the check and the fix. And to show that, so this is the UUID of the last run check that we did. As we review the output here, and I said this will take a minute or two, a few minutes for it to actually go and check the configuration, see what's missing. We found here that we were missing some of the IP interfaces. So when going through the interface, we saw that the IP on 054, 053 was refreshed and what we did to it, as well as interface 64, which is a port channel for our MCT cluster. It gives you a whole report. It will check the underlay config as well as the tenant configuration on the device. So, and that can all be done automatically. It's also done as part of the firmware upgrade process. So if you were to do a firmware upgrade from EFA for the switches, which is supported, we specify where we want to pull the firmware from, and it'll reach out to the switches, put the switch in maintenance mode so no traffic is impacted. A redundant configuration is required for this, so for any firmware upgrade to have no impact. It'll do the firmware upgrade on the switch will reboot, it will check and validate the configuration that it hasn't had any changes that would impact services, and then bring the switch back into production. All this can be done right from EFA, and again, EFA is middleware, so you can run this all from an API from your own management or from XMC.
Alex, that's great. We have about 30 seconds left now, so you could wrap it.
Yep. So hopefully it's giving you an idea of what EFA can do for you. I mean, most of our time here wasn't spent on configuring the fabric. We saved lots of time just automating that onboarding process. And then you can use this at the Northbound API to manage your fabric day to day. So if you need to provision new service between your virtual servers, it's as easy as creating the port group in VMware and then letting the fabric adapt and provision services underneath automatically for you. Now, I'm sure that there's more questions that we missed answering here. So if you have any more questions, or if we weren't able to answer your question today, please visit the hub after Connect here. All the questions will be posted as well as answer those questions. And we'll have other members of our teams here also watching these to answer any further questions you might have. And I believe that about wraps up the time.